Hello, welcome to our video recording of our We are continuing with the routing series on OSPF. Today we are going to look at neighbor, how the OSPF routers discover their neighbors and maintain that neighbor relationship during the whole life cycle of the OSPF configuration. So we're going to look at the Hello packet, which is mainly used for discovering and maintaining neighbor relationship. So let's have a recap of what we learned in the last lesson about neighbor OSPF operation mechanism. We saw that in last lesson, we saw that the router, once you have configured the routers for OSPF, they will undergo through four stages for their operation. They'll go about 4 stages of their operation. So the first thing is you configure the router for OSPF, and we said is good practice to give router an explicit ID to help in your troubleshooting and discovering your topology. So once you configure the router for OSPF, they will form a neighbor relationship as the first. So router A will discover router B as a neighbor, and router B will discover router A as a neighbor. Remember from our previous lesson, I've attached the link to the previous lesson on working mechanism of OSPF, so you can look at it so that you can follow along. Then once they discover each other as a neighbor, they'll start exchanging link state information. So router A will tell router B of all it knows about all the link state it knows about, and router B similarly will tell router B of all it knows about its links. So they'll exchange link state information. And from the link state information, each router will build what we call a link state database. So this router will build a link state database, and router B will create a link state database. From the link state database, each router will calculate the best path using an OSPF algorithm, and router B will do the same, will calculate the best route using the OSPF algorithm, run it on the link state database. So for each of these stages of the working mechanism, we have OSPF uses packets. There's an exchange of packets. So these packets, they are divided into 5. The first packet is called a hello packet. A hello packet, as we have said, it is used for discovering and maintaining neighbor relationship. So we look at it today in detail. And then the next one is called database description. Database description is a brief of a link state database information about a router. So once router A discovers router B as the neighbor, it will tell router B in a brief description that I know about these particular LSAs that I have in my database. Check whether you also have the same. Because we said all the routers in an area should have a similar link state database. So the first thing the routers do, they do not exchange the complete link state information. They start by giving a database description. A database description is like a table of content in a book. When you open a book, it gives you a brief description of each chapter, you see. So I compare this to, I have a movie guy who sends me movies. So what he normally does when he gets new collection, he sends me a list of those new collections, and probably with a trailer of some of them. So, and then I can see whichever I haven't watched already. So I can tell him maybe movie 1 or 2, I haven't watched them. Now he can send the detailed movie, but at first he'll send a brief description of the movies that he has. So it's the same thing, it's the same case with the operation of OSPF router. They will send each other a database description, which is a brief information of all the links they know about, because the link state database is all the links they know about. Then, once it receives that link state database description, it will see that some some of the LSA stated in the link state description, it doesn't have them. So what it will do, it will request for those particular ones that they are missing using a link state request packet. So for me, the person will send me 3 movies, and I'll find that movie 2, I haven't watched it. So I'll ask now my movie guy he has a delivery service, use his delivery man to bring to me movie 2, which is now complete movie, not a trailer anymore, or a description, is a complete movie. So it's the same thing. So I will request that request, I'll place it using a link state request, you see, packet. And then the movie guy will send me now the complete movie. The detailed link state information will be sent using a link state update packet, the link state update packet. So that LSA, if router A had said that I know about router C and router D, but router B said I'm missing router A, send me complete information about router A. So router A will send complete information on an LSU packet about router A. All right. And then because this is OSPF uses TCP, so router B, the neighbor, once it receives the LSU, it has to acknowledge it. So it will use what we call a link state acknowledgement. And let's see whether let's see them in the router. We can come here and let's see from our router, you can see these packets. Let's clear this so that if you display OSPF errors, you display OSPF errors, you should get it, sorry. Okay. Sorry about this. Let me institute an error here. So if you display OSPF errors, you will see that we have, here is the OSPF error output, gives errors about statistics about errors. That is not very important for our description. What we want to see is this packet. You see, we have hello packet, we have the database description packet, we have the link state acknowledgement packet, we have the link state request packet is over here, and we have the link state update packet. So we have 5 major packets: link state update, link state request packet, link state acknowledgement packet, database description packet, and hello packet. So there is normally a question I see in exams of how many types of packets we have OSPF, and those are mainly the packets, the 3 packets. You can see, you can use that command to verify. Now, we look at the structure of each packet. The OSPF packet, because it uses IP, it will still have an IP header. Remember, where you normally contain the source IP address, the destination IP address, checksum, and all those stuff about the IP header. It will still contain IP header because it's a layer 3 protocol. OSPF is a layer 3 protocol using protocol number 89. So after that, we'll have an OSPF packet header. We'll have an OSPF packet header, and then the OSPF packet data. So for each different OSPF packet header, all of them will have a similar packet header, but they will carry different data. For example, a DD will carry the description of the link state database. A hello packet will carry the list of neighbors. You see, they'll carry different information, but the header is the same for all of them. So let's look at the header, how it looks like. The header has the version number of the OSPF. The OSPF we are running is version 2. There is also OSPF version 3 for IPv6. So the one we are running is for IPv4. For IPv6, we use version 3. And then the type. Type means the type of packets. Out of the 5 packets, which type is it? For example, hello packet is type 1. You see? So it will tell us the type of the packet. And then packet length, how long it is from here up to here. So as you continue populating data here, the packet length increases. And then it will give us the router ID that is sending this particular packet. If it's a hello packet coming from router A, it will contain the router ID of router A. And then the area ID in which that router is in, you see. Then we have checksum. What do we use checksum for? Checksum is used for checking errors. If this particular OSPF packet has errors. And then we have authentication mode and authentication data. Authentication mode, there are 3 types of authentication mode. You might decide not to have any authentication, like the OSPF we configured in the previous video did not have authentication. So we use authentication mode null, see? And then you can use simple mode or Cipher MD5. Cipher MD5. Simple mode means the password you use will not be encrypted, which is quite dangerous. So if you decide to use authentication mode in your network, I would prefer maybe use Cipher, because this one will be a plain text password. And then once it specifies the type that is being used, and then this is the actual authentication data, your password. The password will be carried here. So if it is simple, you will see it in clear text. If it's Cipher, you will see it you won't see it, it will be encrypted. So let's have a look at an OSPF packet, the structure. So if we come here and we complete this configuration, we can use OSPF 1, area 0. I have already configured the IP address for the network. So this one was point to point. So if I can use Wireshark to capture the packets here. So I can say start capture, and we can look at the structure of a packet. One of the packets should be a hello packet. So let's wait. You can see we have a hello packet already. We have a hello packet already. It has encapsulation at layer 1 and 2, and then encapsulation at layer 3. We said this is the IP header, and the IP header is version 4, you can see, and the protocol number is 89. But what is very important is the actual OSPF packet. So the OSPF packet has an OSPF header and an OSPF. It has an OSPF header and the OSPF body. You see, just like what we said here, OSPF header and the OSPF body. And so if you look at the header itself, we have the version. We're using version 2 because this is IPv4. We are networking for IPv4. And then the message, the packet type is 1 because it's a hello packet. This is a hello packet, so the type will be 1. And then the length, I would like us to focus on the length. Remember, this length is 44. Maybe you can record somewhere because it will keep changing as we progress, because this packet will carry some data. So it will increase in size. So the packet length for now is 44. And then the source OSPF router, it came from the router ID 1.1.1. So it came from this router 1.1.1. Let's see whether that is its router ID. So if we quit here, quit again, you can display router ID, and you see it's 1.1. So it came from this router 1.1. And then area, it's in area 0. And then the checksum, it tells us it's correct. So it has no errors, you see. And then we are not using any authentication for this. So let's try to configure some authentication. We see how this changes. So let's come here and go into the interface. We configure authentication on interface, and then say OSPF authentication mode. We can give it simple, and then let's just give it a simple password like Huawei. So and then we see whether the new packet has that information. So you see, the new packet changes authentication type, simple password, and the data is Huawei because that's the data we gave. I hope all packets will have a similar header. All the packet types will have this information. All the packet types will have this information. So the only difference will be the content. So for example, the message type for DD will be 2. You see, the type will be 2. The length might be different depending on the data it's containing, but the rest will be the same. All right. I hope that one is clear. So that is the structure of the OSPF packet header. So now we are going to look at the body. So for today, because we are learning about Hello packet, we look at the body of a Hello packet. So the body of a Hello packet. So Hello packet is used for discovering and maintaining neighbor relationship between OSPF routers. So let's see how it does that. So once you configure OSPF here and OSPF here, because before a router hears a hello message from a neighbor, its state is always down. So this one will be down before you configure here. Once you configure here, it will be down, and this one will also be down. So that is the first state. So this one will be down, but once you configure it, after 10 seconds, it will send a hello. To which IP address? To send a hello to 224.0.0.5. Within that hello body, it will contain its own. It will say, remember, we have looked at the packet header. The packet header has one of the items it has is the router ID that is sending. So it will say, I'm router 1.1.1. This is a hello from router 1.1.1, and I have a list of neighbors. The list of neighbors is contained in the OSPF packet body. But I do not, for now, I do not have any neighbor. You see, for now, I do not have any neighbor. So it will keep on sending. Every 10 seconds, it will send to that particular IP address, 224.0.0.5. Now, when you configure OSPF on this, it will receive that packet. It will receive that packet. So it will go from being down to init. What does init mean? Init means I have received a hello message from a neighbor, but in his neighbor list, I did not see my own router ID. Are we together? That's what init means. So I have received, init means I have received, down means I have not received any hello from anyone. But init means I have received, but in the neighbor list, I did not see my own router ID. That's very important to note. So what we'll do, it will also send a hello because it's an OSPF. By default, OSPF will be sending hello every 10 seconds. So after 10 seconds, it will send its own, when it's at init state, it will send its own hello, and it'll say, this is a hello from 2.2.2 and I do not know any neighbor. I do not have any list of neighbor. Then it will say, wait, then it will say, wait a minute, that hello message I received came from a neighbor. So I can take that ID and assume it to be my neighbor, you see? So it will send another hello message, you see? But this time it will indicate that I received a hello from 1.1.1. So that must be a neighbor. So it will include 1.1.1, you see? It will include 1.1 in the list of neighbor. Then this one, immediately it received, it went into init state because it said, I received a hello from my neighbor, but I did not see my own ID in the list of neighbors. So once it receives the second one that has a neighbor, it will say, but that neighbor, it's my own router ID. So once it sees its router ID in the neighbor list, it transitions from init to two-way. So two-way means I have received a hello and I have seen my router ID in the neighbor list, you see? So two-way, you see? Two-way. So it will also send a hello, but with this time, it will contain a neighbor 1.1, right? Because it already has a neighbor 1.1. So once now router 2 receives that hello packet, it will see its own ID in the neighbor list, and it will transition to two-way. So two-way is a stable state. That's when we say now that neighbor relationship has been established. When it's two-way, a neighbor relationship has been established. Okay. So this is a brief description. When it's at down state, we are saying the OSPF has not received any hello packet. In the init state, the OSPF router has received a hello packet, but has not seen its own router ID in the neighbor list. So it has received a hello, but in the list, it hasn't seen its own ID. And then in two-way, the OSPF router has seen its own router ID in the list of neighbors. It has seen its own ID in the list of neighbors. And the two-way is a stable state. They normally come a question, which is a stable state neighbor relationship? Two-way is a stable state. So when you see two-way when you display OSPF peer brief and you see two-way, you are okay. No need for panic. Because normally on your display, we will see that one with configuration, how it comes to play. So let's try to finish and see how this one works. So here we have configured OSPF on this side. OSPF peer OSPF interface. So we already have on 1.0 on 0.1 interface. So we also configure on the other side. So we go to, need to configure on this side. We configure let's clear this. So we configure OSPF here as well. So let's go to system. Let's display router ID. It also has a router ID. No, this is not the router ID that we want. We want router ID to be 2.2.2. And then you can configure OSPF1. And then we go to area 0. We are still on area 0. Network 192.168.0.0, 0.0.0.3. So display this. Sorry, it's like my computer is hanging. Yeah, so we can display OSPF interface. I have seen this interface and the state is waiting. So remember we configured a password here. If you display this, on this interface, we configured a password. For it to work, it has to be the same. It has to be the same on the other side as well. So we come here, interface G0/0/0, and we say OSPF, authentication word, simple, Huawei, like that. So you can see there's, let's see whether we can sift through this information. We can see at this point, sorry, this one, it goes to full. Let's start from here. Process 1, neighbor address. It discovered a neighbor on, it received a packet from a neighbor. You see, hello received. It has received a hello, and it has transitioned from down to init because it received a hello from the neighbor. It received a hello from the neighbor and transitioned to init. You see, at that point. So let's see whether from our packet, and then here, it received two-way received, you see, two-way received, meaning it has now seen a packet which has in its list of neighbors, it has its own router ID. You see, its own router ID. Let's look at our capture and see what we are getting. So if we go to earlier, because we had, we come here, we come, where do you see hello? Here we come, hello here. We see this has been sent with a simple, this is where we stopped last time, with a simple password. If you look at the packet data itself, you will see neighbors. You see, let's see, at least there is no neighbors, you see. There's no neighbor anywhere. There's no neighbor anywhere in this list. So if you continue down here, and you see, you remember the length of the packet is 44. Let's note that. The length of the packet is 44. So if you come here and observe this, you see this one, this is a hello packet now, but it has some different parameters. If you look at the length, it's now 48. Remember the other one was 44. This now is 48. Because if you look at the body, there is a neighbor. You see, there's a neighbor that has been added, an active neighbor. So it has discovered that I have an active neighbor 1.1. You see, are we together on this? There is a neighbor, and now we have also a database description packet. We'll look at that when we come to look at adjacencies. You see, so that's what we're talking about. So we have said when you display OSPF tier here, let me clear this so that we do not have a lot of, we have a clean screen. So if you display, let's display OSPF peer brief. We see there in full state. We do not see two-way. We'll talk about that in our next video. But there are two stable states you can have, full and two-way. Let's look at this other configuration that we'll talk about in the next lesson. If you come here We can clear this. We can come here and display OSPF peer brief. Okay. Sorry for this. No, why this one is behaving there, it's behaving. Display OSPF peer brief. Okay. 4.4, what is happening to it? Let's configure this one. It seems it has lost the configurations. Let's quit fast and do the router ID, and this is 4.4.4 OSPF1 area 0 network 192.168.0.0 0.0.0.255. Let's see whether it will have a relationship with this. Sorry guys, it's not coming up. Seen something wrong with the ENSP2. Sorry guys, let's see whether it will come up. It's not coming up for some reason. Ping 192.168.0.1. The router is not coming up. Self. Sorry about this. Sorry, let's wait for it whether it will behave again. Seems there's a problem with the problem with the ENSP. Let's try to see whether it has come up. Not yet. Not yet. I think there's a problem with that. It should have come up by now. Yes, it's up now. Let's see whether we can have OSPF running. Still not having OSPF running. Can't show me an interface. Okay. Let's do a different router. Let's do a different router here. We remove this connection from here. We can do this. Just stop this router. I haven't deleted it. Let's see whether this one will behave. Guys, sorry for that. It seems ENSP has a problem today. So let's rename name R8. Okay, sorry. Interface G0/0/0. We give it an IP address 192.168.0.2. This is 24. Display IP interface brief. Let's give this one a router ID of 4.4.4. No OSPF 1, and then area 0, and then we give the network 192.168.0.0.0.0.55. Display this. Display OSPF interface. Yeah, this one now has a name. You see now this one is okay. Don't know why it is in the waiting state. Need to be 92.168.0.1. Can't ping. Can it ping itself? .2. This can ping itself. .3. I do not know what has happened to the routers. All of them. Okay, guys. .3 I can ping. .4 I can ping. So why is it I'm not able to ping .2? Let's see, .2 I can ping now. I can see now this one has come up. So this one is okay now. We can see what I wanted to demonstrate. So if you display OSPF peer brief here, you will see that I have with router 5, I have full, and with router 6, I have full. But with router 3, I have two-way. It is correct. It is okay. If you see your network that the neighbor state, some of them are two-way, but others are full, it's correct. So the stable state of neighbor relationship is either two-way or full, as you can see from here. So because we are looking, when we look at adjacency, we'll see when it becomes full. But here, two-way is a stable state. So there are two stable states for neighbors, two stable states for neighbors, two-way or full. And you've seen how two-way comes about. We shall see how full comes about when we look at at adjacencies. So for now, we know how two-way comes about. Okay, so let's look at the format of the Hello packet. So Hello packet has the network mask. The network mask. Remember when we are doing the wildcard mask, the network, when you're describing the network, then the network IP and the wildcard mask. This is where it comes to play, the network mask. Then the hello interval. It means how long will I wait before sending a hello packet. So I'll send, by default is normally 10 seconds. And then router priority is used in the designated router and backup designated router election. We'll see that when we come to look at network types. So for now, this one you can ignore this, but hello interval and router dead interval means every 10 seconds, I will send a hello. If you have not received hello in this time, just declare me dead, all right? And tear down that neighbor relationship that we had. So the router dead interval will mean if I don't receive a hello from you within this time, I'll declare you dead and bring down that neighbor relationship. So the router dead interval is normally 4 times the hello interval. So if this is 10 by default, this one will be 40. So if I don't receive a hello message in 40 seconds, I'll declare the neighbor dead and I'll tear down that relationship. Are we together on that? I hope you are together. Then it will contain a list of neighbors. The hello packet will contain a list of neighbors. So we can go back to our capturing and see whether that is the structure of our hello packet. We had this hello packet. So you see the hello packet, it contains the router, the interface that is sending this message. It was a stroke 30. So 255.255, it will have a network mask. And then you can see hello interval is 10 seconds. 10 seconds. Then priority, we'll talk about that later. Then the dead time interval is 4 times by default. It's 4 times the interval. It's 40 seconds, the hello interval. And then designated router and designated backup router. Then the neighbor, you see? Then the neighbor. So that one complies with what we have here. So you can have as many neighbors as possible. So what I want us to look at is, why do we need to learn that? It's because some of these items must match, like the network mask. The network mask on both sides of the interface must match. If it's not matching, you'll get an error, a neighbor error. Hello interval should match. If they're not matching on the two routers, you'll get an error. All right? The router interval, the dead time interval should be the same. So we are going to look at the common neighbor problems. So one of them is mismatch on the authentication mode. So supposing, let's go back to here we had authentication. So remember, we already have a neighbor display, OSPF peer brief. We already have a neighbor, which is 2.2.2. Supposing we had authentication on this router, remember? Supposing we change the authentication mode. So let's go to system and we go to interface G0/0. We change if you display this, you'll see this mode, and we configured the same mode on the other side. But supposing now we change this, we undo this, undo OSPF. Authentication mode, just undo. By just undoing, Now, the authentication mode in this one is null, because we said if you're not using authentication, the authentication mode is null. So if you display OSPF here, brief, it has not turned down yet. Let's reset, because it will have to wait for the 10 seconds. We don't have 40 seconds. We don't have that time. So let's reset this. And then we display brief. You see, we don't have a neighbor. You see, we do not have a neighbor now. Because why? We won't know until we say display OSPF error. Remember that command? It will tell us where the problem is. So when you come to look at it, it will say there's 3 bad packets. You see, 3 bad packets, 3 bad packets that you have received. So we have received 3 bad hellos, 3 bad hello. And if you come here, the error is in here, bad authentication. You see, those 3 packets had bad authentication type. You see, bad authentication type. So we can fix that. We go back, interface G0/0, and we give it back to what we had. So that we can solve that error. It was simple, and the data was Huawei. So if we display OSPF here, it's now come up. Brief, you can see already it's come up now. You see, that is one of the common errors with neighbors. The other one is mismatching hello packets. So mismatching hello packets. So for example, if here I say OSPF hello, OSPF timer, hello, I want to send my hellos in every 5 seconds. So if I do that, I want to send my hellos every 5 seconds. So reset. The other side we have not changed. So it's still 10 seconds. So let's see. So if you display OSPF here, brief, we don't have any neighbor. Why? We can display OSPF error and see what we have. It will give us a general description here. It will tell us there is a bad packet. And which bad packet is that? It's this bad packet. You see, hello packet. It has a mismatch. Hello. It has a mismatch. Hello. You can see that. A mismatch. Hello. It has received 2 packets that had a mismatching hello type, because we expect the hello times to be the same. So we can go back and interface G0/0/0 and return. We undo this so that it remains there it was. You can see it here changed me to init. So maybe display OSPF here brief. We have a neighbor back. So the other one is mismatching area. If the sending router interface is in area 0, but the receiving one is in another area, maybe area 1, it won't work. It won't work. And the network mask of the sending interface. So for example, if this interface, this one, if we display this interface is /30. Supposing we make it /24. So copy, paste here. We make it /24. You see the neighbor has immediately gone down. So if you display OSPF neighbor, OSP, sorry, still thinking Cisco type. Sorry, peer brief. You see there is no neighbor. So what we see, display OSPF error. So if you display OSPF error, it will say it has received 7 bad packets. So which bad packets are those? We continue looking, we'll come and see it's a hello packet. And the problem is there is a mismatch, network mismatch, you see. Okay, sorry, let's see. A network mismatch. So we fix it, we return it to how it was, 252, and display. It is back now, display OSPF peer brief. See now we have. So those are the common errors, the common mistakes that you're most likely to incur, that maybe the sending interface is in one area, but the receiving interface is in another area. Mismatch of hello. Data, maybe here you used Huawei, but on this side, other side, you use Cisco. The authentication mode and data must match. And the network mask on both sides must match. So that one marks the end of our neighbor, our OSPF neighbor lesson. The next lesson will be on adjacencies. So thank you for watching, and please subscribe so that you can get notified when we release another video like this one. Thank you and good day.